Alright, so 15, the limit as x goes to negative 1 of 2x squared minus x minus 3 over x plus 1. Alright, so I'm going to go over here and factor this. This is bust them up. It's got to multiply to give you 6, add to give you negative 1. It's going to be 2x squared plus 2x minus 3x minus 3. So I'm going to input that into the problem. What can I cancel out now? Very good. Now I'm going to plug negative 1 in. 2 times negative 1 is negative 2 minus 3 equals what? Negative 5 is my answer. Alright, we're going to skip 16. I'm not going to give you one like that. Number 17. The limit, yes, trig can appear in these, as x approaches pi of tangent of pi. Tangent of x, I'm sorry. Try direct substitution. I plug in pi. Pi is negative 1, 0. What's the tangent of that? That's your answer. Number 18. The limit as x approaches 7 of secant pi x over 6. I'm going to plug in 7 for x. Secant of 7 pi over 6. Okay, well, we know that pi over 6 is root 3 over 2, comma 1/2. They're in quad 3. They're both negative. I want the secant of that, so I'm going to flip my cosine. Rationalize, so my answer is negative 2 square root of 3 over 3. Are there any questions on those three? Okay. Let's look at 19.
If it came out undefined for like one of the trig ones,
then your answer is just undefined. Or just put does not exist. Number 19. The limit as x approaches 3, x plus 1 minus 2 over x minus 3. I plug 3 in, I get 0 in the denominator, so I got to pick up a strategy. What strategy am I going to do? So I'm going to multiply the numerator and denominator by x square root of x plus 1 what? Plus 2. Alright. 4. This times this, what happens to those square roots? Cancels out. This times this is plus 2 square root of x plus 1. This times this is minus 2 square root of x plus 1. And then negative 2 times 2 is negative 4. Now watch this. This is one thing, isn't it? Never mind. Stop. I didn't say that. Here we go. I didn't say that. 1 of 4. Here we go. This times this is that. This times this is 2x. This times this is negative 3 square root of x plus 1. And this times that is negative 6. You're foiling. What I should have said is that is considered one thing. X times that, x times this times this times that. Take a moment to make sure you agree with that. Alright, these two cancel out. I clean it up. That's going to be x. 1 and negative 4 gives me negative 3. And then I have this mess. So what I need to do is see if that's still equal to 0. If not, then I can go forth. But if not, I got to do another strategy. 3 plus 1 is what? 4. Square root of 4 is 2 times 3 is 6, okay? 2 times 3 is, that's 12, okay? 3 plus 1 is 4, the square root of 4 is 2 times negative 3 is, so I had 6, 6, negative 6, negative 6, it's still 0, isn't it? So I'm going to factor. So what I'm going to do is, what can I take out of those first two? X. What can I take out of the bottom two? A negative 3. So that's what I'm going to have to do here. Alright. So we got x, that leaves a square root of x plus 1 plus 2 minus 3 square root of x plus 1 minus plus 2, I mean. So that leaves me x minus 3. You got x minus 3 square root of x plus 1 plus 2. What happens to these x minus 3's? Cancel. I'm left with 1 over square root of x plus 1 plus 2. I'm going to stop there for just a second. Are there any questions so far how I've got where I've gotten to? You good, Jackson? Eric, is it making more sense though? You sure? I plug 3 in. What's 3 plus 1?
4.
Square root of 4 is?
2.
2 plus 2 is?
4.
So your answer is 1, 4. And the last one, number 21. The limit as x goes to 0, x squared minus 3x over x. If I plug 0 in, I get 0. So I got to do this strategy. What strategy do you think I need to do? Factor. Factor x out. X cancels out, and I plug 0 in. What's 0 minus 3? Negative 3 is your answer. Are they? Yes, hon. Oh, I skipped number 20. Thank you. All right, number 20. The limit as x goes to 1 of pi over x2. I plug 1 in, I get pi over 2. What is the sign of pi over 2? 1. That's your answer. All right, now we got 15 minutes to do a few things. Here's what we're going to do. I'm going to go on and give you 2 checkpoints today. You're going to do one. You should finish the first one. Just finish the second one. We can finish that tomorrow, but most of you will finish both of them. After you finish those 2, you can just work on your homework, which is these continuing, okay? Does everybody understand? Also, I do this every year. Next week is Teacher Appreciation Week here at Thompson. Now, I don't know why it's not. But normally, it's always the first week of May, but Thompson always does it on a different week than the National Week. All right, so I give everybody 2 pieces of paper. You're going to write appreciation notes to your teacher. How many teachers do you have during the day? Most of you have how many? 7. So write to any of those 7, okay? You got me? I'm going to find a common denominator. So the common denominator would be 3 times 3 plus x. So let's try to get these in by Friday. On 23, take the to the left off and just say do x to approach is 4. We ain't learned how to do one-sided algebraically yet. These notes can just be turned in by Friday. Or if you get done with everything, you can do them today.